how does our product work, and why is it different than cylinder breaks? Well, we're using piezoelectric sensors to actually create a wave that pushes itself into the concrete as it's curing. And that way we're measuring the impedance or the resistance or the pressure that wave is pushing against the cement. And the really interesting thing is that when you look at pressure, and here's a representation of what that wave pressure looks like as the frequency is changing, that when you get to the resonant frequency of the structure, you will see the wave itself grow. So there's a lot of back pressure here on the wave. You can see the wave, it's getting this pressure. And when it hits that sweet spot or the resonant frequency, boom, now you get all this energy. You have no resistance or very little resistance, and you see that wave grow. If we plot that and we look at where the least resistance is for that wave, we can see a defined peak in that frequency. And we run the frequency from 20 hertz to 200,000 hertz. You're going to find that peak. Now, what's so interesting about that peak? Well, for number one, we found that peak non-destructively. We didn't have to crush a cylinder. We see that peak. But that resonant frequency of that structure is proportional to the modulus of the structure, and the modulus is proportional to the compressive strength. So by knowing this point of the resonant frequency, or this frequency, we can determine the compressive strength in real time without a destructive process.